All right, we are going to solve one of the most annoying mysteries of the digital world. You know the one. Why your perfectly good text sometimes just turns into a bunch of question marks. We've all seen it, and trust me, the answer is surprisingly straightforward once you see it.
Yep, we've all been there. You open an email, you click on a web page, and the text is just complete gibberish. Now, this isn't some weird bug or a virus. It's actually a fundamental misunderstanding between computers. And today, we're going to clear that all up. So to guide us through this, we're going to lean on a classic, fantastic article by the programmer Joel Spolsky. And, well, his take is pretty clear. For anyone who works with computers, understanding this stuff isn't just nice to have, it's absolutely essential. And this really gets to the heart of the matter. This idea that there's some simple thing called plain text is, honestly, a dangerous illusion. It's like being a doctor in the modern age and not believing in germs. It's an outdated way of seeing the world, and we need a new one.
Okay, so to understand why things got so complicated, we have to go back to when they were simple. Let's hop in the time machine and take a quick trip back to the dawn of modern computing. So back in the 60s and 70s, the digital world was, well, it was a lot smaller, and it was overwhelmingly English-speaking. All these foundational systems like Unix and C were built with one and only one language in mind. And you know what? This assumption worked perfectly for a while. The standard that made this simple world possible was called ASCII. And it was brilliant, super efficient. It used 7 bits of data to represent 128 characters. That's everything you need for English, plus numbers, punctuation, the whole deal. The number 65 always meant A. It was simple, it was reliable, it was universal. As long as you were an American.
But then, surprise, surprise, the rest of the world wanted to use computers too. And see, computers used 8-bit bytes, which left 1 extra bit, or 128 extra slots. And this, right here, is where the chaos began, because everyone had their own idea of what to do with those extra numbers. And this slide just nails the problem perfectly. Take the number 130. Depending on what code page your computer was using, that same number could mean a totally different character. So an accented E in one place was the Hebrew letter Gimel in another. It's the exact same data, but with a completely different meaning. The real-world result of this was just a total mess. A simple resume would get completely garbled. Trying to send a document in Russian was basically a roll of the dice. And for languages like Chinese or Japanese, with thousands and thousands of characters, programmers had to invent these super clunky systems. It just wasn't sustainable.
Thankfully, a group of very smart people realized this chaos just couldn't go on. They came up with a bold, ambitious, and frankly beautiful idea to create a single unified character set for every single language on planet Earth. And this was the birth of Unicode. Now, before we go any further, we have to bust the biggest myth about Unicode. It is not just a simple system where every character is stored in 2 bytes. That was an early idea, yeah? But the reality is so much more elegant. The true genius of Unicode was a philosophical shift. It separated the idea of a character, the abstract, platonic ideal of a letter A, from the actual physical bytes you use to store it on a disk. This, right here, is the absolute key to understanding everything else. So, in this new Unicode universe, every single character from every language gets a unique number. It's called a code point. Think of it like a universal serial number. U plus 0041 will always, forever, mean the character A, no matter what computer you're on, no matter where you are in the world. So, a simple word like hello isn't really a sequence of bytes anymore. At this stage, it's an abstract sequence of these code points. It's just a list of numbers. See, we haven't even talked about how to save this to a file yet. We're still in the world of pure concepts. Okay, so how do we get from these abstract code points to actual physical bytes that we can store and send across the internet? Well, that's where encodings come in. And encoding is just a set of rules for turning those code points into bytes. One of the first tries, called UCS2, was basically, hey, let's just use 2 bytes for everything. Simple, right? Well, not so fast. It immediately created a new problem. Different computers store bytes in different orders, so this led to inventing a special, invisible character at the start of a file just to tell the computer which way to read the bytes. It was getting complicated all over again. And on top of that, there was pushback. I mean, for plain old English text, using 2 bytes for every letter felt incredibly wasteful. It literally doubled the size of every file, for no good reason. As Joel Spolsky hilariously puts it,
This resistance from American programmers is what pushed everyone to invent a much, much cleverer solution. And this slide shows that solution perfectly. It's called UTF-8. Now just look at this. The word hello in old school ASCII is 5 bytes. In that 2-byte system, it's 10 bytes padded with a bunch of zeros. But in UTF-8, it's exactly the same as ASCII. This is the genius of it. For English characters, UTF-8 uses just 1 byte. For other characters, it uses 2 or 3 or more if it needs to. It is the best of both worlds. Okay, we have covered a lot of ground here, from ASCII and code pages to Unicode and UTF-8. So if you remember only one single thing from this entire explainer, please let it be this next point. And here it is. A string of text is meaningless without knowing its encoding. The bytes in a file, they're just numbers. To turn them back into characters, you have to know what rules were used to make them. Was it ASCII? Was it UTF-8? Was it something else? Without that crucial piece of information, you're just lost. Which brings us to our final profound truth. There is no such thing as plain text. Every single text file, every string of text in your code, every email, it has an encoding whether you know it or not. Pretending it doesn't is the root cause of all those question marks. And so we'll leave you with this one critical question. When you create content, when you save a file, when you build a website, do you know what encoding you're using? Because now you know that's the difference between clear communication and a screen full of gibberish. Thanks for joining me on this one.